I'm Miguel Romo, Aceves, and this is my events 2 of Mechatronic system. Well, first of all, the problem. We need to help a client with the automatization of an industrial curtain. We need to give him a solution that will satisfy all his requirements. For example, he asked for a security system to work in modes for the curtain and other things. We also need to give him an efficient and economical solution. And for doing this solution, I use primarily two technological tools. First, Logisim, that's a program that I used for simulating the through tables and the circuits, and LabVIEW. With LabVIEW, I did a virtual solution, a virtual prototype of the solution that I can use to present to the client. But first of all, I did a little bit of background. I searched another solution of other enterprises to see how they did it. And so that way I could have an idea of how to do my solution. First of all, I found the solution of FAAC. They used two actuators. One actuator, they use a motor, a 230 volts gear motor, and they use sensors only to photocells. They also have an electronic circuit to control all the system, and that's all of this. The second solution that I found was made by DTEC, and it's very similar as the other one. They also use an electronic circuit for controlling the system, and both of them have a panel. This solution uses a flashing light as an actuator and the motor as well as an actuator. And for sensors, they use a limit switch and photocells. And viewing the solutions, I came out with two areas of opportunities to improve these solutions. First of all, I think that they could add an auto mode, because both of these solutions only had a manual mode that you need to press the button so the curtain go up. You need to stay press the button, and you can add an auto mode so that you only need to press once the button, and they could add a security system, because both of them didn't have a security system. This will add more security to the system and will make it safer for everyone. So first of all, to solve this solution, what I did is I look up the variables of the problem and I give them values for the condition for 0 and the condition for 1. First of all, we have the upper limit switch, that this will be a sensor that will detect if the curtain is up. This sensor is a little bit down the position of the curtain at the top. This way, the system will work fine, because if the limit switch is up at the same position as the curtain, it will have problems with the logic equations. 0 is it's 0 if the sensor doesn't detect anything, and 1 if it detects the curtain. The lower limit switch is the same. It has the same conditions for 1 and 0 as the upper limit switch, but this limit switch is the lower limit, so it's almost touching the floor. I also put an ultrasonic sensor that it will detect objects below the curtain. 0 for when it doesn't detect anything, and 1 when it detects something below the curtain. It will also have, for the manual mode, both a raising and lowering button. This button has the same conditions: 0 when they are not pressed and 1 when they are pressed. The emergency button will be only used for the auto mode, or the automatic mode, and it will have also the same conditions: 0 for when it's not pressed and 1 for when it's pressed. This emergency button will work in a way that when it's pressed, the automatic system will stop. And the output variables are the following. First, the motor variable. Well, the motor will be the one that moves the curtain up and down. The condition for 0 is when the motor goes down, and for the condition for 1 is when the motor goes up. We will also have a brake. The brake will help the curtain to stay in the same position. When the brake is off, the condition is 0, and when the brake is on, the value is 1. Here it's very important to say that when the brake is on, when it has a value of 1, the motor will be turned off. And lastly, we have the security system that, as I said, this will turn off. This system will turn on when this ultrasonic sensor detects something below the curtain, an object or a person. And when this happens, the security system will turn on an alarm, and it will also record everything with the camera. The condition for 0 when the security system is off, and the condition for 1 is when the security system is on. And having these variables, I did these two truth tables. And we can see they had a lot of excess don't cares that I treated in the next slide that I will show. But first of all, it's important to say that the equations of these tables are very large, and I didn't write them because they are not that useful and we will not use them. So I decided to not write them. But here it's the next step to the solution. It's the optimization of the process. Having the answers of the truth table, the solutions, what I did is first of all put these solutions in a map of Carnot. In this map, I need to separate the values of the variable, of the output variable. For example, in this case, the output variable is the motor in the manual mode. I did this, and when I had all the zeros and ones, what I need to do is to group. We need to group all the ones, making groups of two, for example, 2, 4, 8, 16, etc. And doing this, we can eliminate variables. For example, in a group that has, we need to see the variables within the groups. And if in the group, one variable changes, it could be eliminated. This is because of the Boolean rules, logic rules. So for example, here I have the down, it's right, below is right the equation of this table, of this manual mode for the motor. And we can see it's very short. And we can see that I did the same for the four maps of Carnot. Because as we can see, the truth table had 4 options, 4 outputs, 2 for the manual mode and 2 for the automatic mode. So doing this, I had 4 equations, but they're very shortened, comparing them as the original equation. So after I got the minimum equation for each variable, I put them in LogicSim to simulate them. As we can see, the circuits are very simple. They only have AND gate, OR gate, and NOT gate. And we can see that they're very simple. And we have 1 circuit for each table, for each equation. We can see we have 4, 2 for each mode. So now we can go to LabVIEW to see the simulation of how the curtain will work in each mode. First of all, we have the manual mode. In this mode, as we can see, we press the button down, the curtain will go down, and we press the button up, it will go up. We can also stop the simulation with this button. And here is how it works. Here we can see that a number enters this loop, this for loop, and in the upper part, 4 is subtracted to this number 14, so the curtain will go down. And here the 14 sums 4, so the curtain will go up because there it is adding 4 to the 14. Here we can see the inputs of the system that are the buttons down and up. And here's the output. So as we can see, here is the automatic mode. When we press it, when we run it, we can see how the curtain goes up and then it will go down. We can also put an object here with this button. When we turn the object, it will go up and the alarm will be set on. We can also stop it with the stop button. So here's how it works. We can see that it's a very similar one function as the manual mode. We can see that, but here instead of having buttons, we have a number, and this number will be the one that will go that will add or subtract. And having this, we can do the automatic mode. We can also see that here's the object. If the object is on, the alarm will be on. And that's all. We can see that it has a position and cycles too. And now we can go to the last part. That now that we got a solution, I will talk about the problems that I had during the design process. First of all, I had problems thinking of how to put each variable, the values of each variable, especially the motor. I didn't really know how to do it. And I had problems with LabVIEW because I didn't practice enough, because I had problems downloading it, but I could do all of this work. Solving the problems, well, to solve the problems, I used YouTube and Google, and with this, I could solve the problems and asking the professor too. And that's all for my evidence. Thank you.